Hi, everybody. In this lesson video, I'm going to go through 3.2, logic and reasoning. So we want to first define a conditional statement. Which actually I'm just going to do it this way. Conditional statement has the form if blank, then blank. And this first statement, P, before the then, right? After if, but before then, this statement P is what we call our hypothesis. Then Q. Oops, and I meant to write P using that blue color. So if P, then some other statement Q might occur where Q is our conclusion. Conditional statements can be true or false, just like a statement we had in math. And excuse me, a notation we might see to represent a conditional statement, if P then Q, would be P implies Q, which means statement P implies statement Q. If statement P is true, then statement Q is also true. So this is what that means. So an example of a conditional statement: if an angle measures less than 90 degrees, then it is an acute angle, or it's an acute angle. So our hypothesis here is the if part. So if an angle measures less than 90 degrees, so if we have this angle measure that's less than 90 degrees, that's our statement P. Angle measures less than 90 degrees. I'm just using the less than symbol to abbreviate here. Then it's an acute angle. So our conclusion, if statement P is true, if we have an angle that measures 90 degrees, our conclusion is it's an acute angle. So I would say here, statement P implies statement Q. If an angle measures 90 degrees, then it's an acute angle. So when we have a statement in general, like an angle measures 90 degrees or an angle is acute, we can find the negation of that statement. So the negation of a statement makes it not true. It negates it. Makes it true. So if our original statement is statement P, then our negation would be not P, which can be seen with this kind of little approximate symbol, or sometimes we see this little I don't know what that's called actually, but this can be used to represent the negation of statement P, and it kind of looks like a bar with a little tick going down on the left side. But both of those mean not P. Makes it not true. The negation makes it no longer true. So some examples of this. We're going to look at some original statements, and then we're going to negate them. So my first original statement is going to be, I am tall. The negation of that would be, I am not tall. Another example, a math example, the polygon is a square. The negation of this statement, making it not true, the not version of this statement is the polygon is not a square. So that's going to become kind of important here as we start to work with our conditionals, because when we have a conditional, oftentimes we are going to be asked questions where we need to manipulate the conditional. So manipulating a conditional. How can we change it in different ways to make the statement mean different things? So I'm going to have an example here. So our original conditional is, if I have my driver's license, then I am at least 16. And I wrote it this way on purpose. So if I have my driver's license, then I am at least 16. This is our conditional. Our P implies Q. No, P is I have my driver's license. That is our hypothesis. Q is I am at least 16. So altogether, this conditional statement is P, if I have my driver's license, that implies that I am at least 16 years old. So we can kind of change this up in different ways. The first thing we can do is we can find the converse of this statement. So instead of P implies Q, this is Q implies P. We just flip the order. So instead of if I have my driver's license, then I am at least 16, this would be if I am at least 16, putting Q first, if I am at least 16, then I have my driver's license. I'm going to say license here. So our converse flips the order. Instead of P implies Q, it is Q implies P. Your inverse, if I find the inverse of our original conditional, that is not P implies not Q. So I find the negation of P, and that implies the negation of Q. So I'm going to find the negation of these. If I am not at least 16, oops, I did it backwards. I was looking at the converse. I was looking at Q implies P. I need to do P implies Q. So I'm going to start with P first, but find the negation of it because we're finding the inverse now. And P is if I have my driver's license. So if I do not have my driver's license, my bad. If I do not have my driver's license or have my license, then I am not at least 16. So that would be our inverse. Not P implies not Q. The last way we can manipulate this statement is we can find the contrapositive. And the contrapositive we get when we take the converse and we negate it. Or we take our inverse and we find the converse of that. So you either flip it and you make it so that Q implies P and then you negate that, or you find your inverse, not P implies not Q, and you flip it. So your contrapositive is not Q, or not your conclusion. The negation of Q implies the negation of P. So looking at what Q was, remember Q is I am at least 16. So starting off our contrapositive, if I am not at least 16, oops, come on. If I am not at least 16, then I do not have my license. I take Q first and I find the negation of that. So if I am not at least 16, then the negation of my hypothesis must be true. Then I do not have my driver's license. That is what the contrapositive is saying. Not Q implies not P. All right. Next, I want to talk about a biconditional. So we were talking before just about conditionals. Now I want to talk about a biconditional statement. So a biconditional statement says that P is true if and only if Q is true. And the way this looks, if we're just using our kind of symbolic notation, P, and then we have a double arrow. P, if and only if Q. P is true if and only if Q. And really what a biconditional statement is it's two conditionals. We have an original conditional, we have P implies Q, and then we have the opposite. Q implies P. So really, we have a conditional and its converse. We have a conditional statement and its converse statement. So for example, a triangle is isosceles if and only if two sides are congruent. So this is an example of a biconditional. And if we wanted to prove that this is true, we need to prove, first of all, that a triangle is isosceles, or sorry, if a triangle is isosceles, then two sides are congruent. That's one thing we need to prove. That's part of it. Part of this biconditional. The second piece is T. The second thing, the second piece is the opposite, going the opposite way. If two sides are congruent, then the triangle is isosceles. So here this is P implies Q, right? P is that the triangle is isosceles. Here's P implying Q, that two sides are congruent. And then we flip it. And this is also saying that Q implies P. If two sides are congruent, or if Q is true, then P is true. So biconditional works both ways. All right, I am going to create a separate video going through some examples. So please watch that video after you are done taking notes on this one.